Hey, I'm Google. Welcome to Learning Biology with Google. No, I'm not Alexa. Today I will be teaching you about human digestion. It's pretty gross. I prefer computer science. No titty, no shade. Anyways, let's get this done with. First, chewed up food enters the mouth and is coated with saliva produced by salivary glands containing lubricants and enzymes to start starch digestion. Thus, Mr. Bolus is born.
Oh, I'm Bernie Bolus. I'm what you swallow and what you poo.
And his digestive journey begins. Peristalsis, the contraction of smooth circular and longitudinal muscles, pushes Mr. Bolus on his way. Through the esophagus tunnel, we go. Who drew this? They should never draw again. I could draw better and I don't even have hands. Mr. Bolus enters the stomach.
Whoa, quite the roller coaster ride here. Actually, I'm starting to feel a bit seasick.
The movement Mr. Bolus feels is due to the mechanical digestion of the stomach, called churning. In here, Mr. Bolus will be digested for
many hours later,
until he turns into a creamy paste. Now, from here on he should be called Mr. Chyme. But Mr. Bolus doesn't want to change his name, so let's let him be. Make haste, you silly paste. Ha ha ha, I am so funny.
I'll take all the time I want, and you can't stop me.
The stomach contains digestive acids. This causes proteins and other macromolecules to denature, helping the digestion of Mr. Bolus overall. Proteases from the pancreas, such as pepsin, enter the stomach to help digest the protein in Mr. Bolus. As Mr. Bolus exits the stomach to enter the small intestine, the pancreas will release alkaline compounds to neutralize the stomach acid. As Mr. Bolus exits the stomach, he moves along the intestine with peristalsis.
Whee!
Peristalsis was also used to move Mr. Bolus in the esophagus. However, in the small intestine, Mr. Bolus moves much slower to allow more time for digestion. The main function of peristalsis in this case is to churn Mr. Bolus with other enzymes to speed up his digestion in the small intestine. When Mr. Bolus is traveling in the small intestine, the pancreas will secrete enzymes into the lumen such as lipase and amylase to break down the nutrients in Mr. Bolus. Then, the wall of the small intestine will create other enzymes to digest Mr. Bolus further, such as lactase and maltase.
Oh no, you're breaking my double bonds.
Some of those enzymes will be secreted, but most are immobilized in the plasma membrane of the epithelium cells in the intestine. Since the small intestine is very long, Mr. Bolus will take hours to pass through, allowing most macromolecules to be catabolized into monomers. The epithelium cells of the small intestine absorb nutrients from the digested Mr. Bolus, which is aided by the extra surface area the villi contributes. These nutrients mainly consist of mineral ions and monomers. When the villainous villi have robbed poor Mr. Bolus of all his nutrients, the intestine will start a process of assimilation and transport the products of digestion to various different tissues. Nutrients are absorbed by the epithelium. They must then move to the center of the villus where they can access blood capillaries. The nutrients are transferred using various processes, such as diffusion, facilitated diffusion, active transport and exocytosis. Mr. Bolus can provide the body amino acids from the proteins, the nitrogenous bases from the nucleotides, and others. These molecules will then be used to build larger molecules that become part of the body.
You can take my nutrients, but you can't take my pride.
Time for the last stage, the large intestine. In the large intestine, Mr. Bolus, who is now hardly a bolus, is digested even further by symbiotic bacteria living in the large intestine. Water is reabsorbed by the large intestine. Finally, Mr. Bolus goes under his last transformation and becomes feces and pops out. That's disgusting. I hate humans.